So I decided to change our topic of the lecture number 7. We plan to have lecture number 8 for UML, and then lecture number 7, sorry, for UML, and then lecture number 8 for the more details about UML. But I decided that it's too much about UML. There will be enough to have just one lecture about UML. But instead, we're going to talk about data formats. And XML, I believe, is one of the most important, the most interesting format of data. So lecture 7 will be about XML, and then today, later, lecture 8, we talk about UML and the model-driven architecture, which is something on top of UML, which is interesting. So once again, a few words about the grading schema which we're going to have. So as you know, the final result, the final grade you're going to get according to the project which you will create. Let's call it pet project or course project, whatever you call it. You just select the topic, you make the software product, you make the product well designed, and your design has to be well explained. And at the end of the course, you present your project to your team, to your teaching assistant, TA, and the TA will look at your stuff, what you created, and give you some scores, some numbers. And we're gonna grade you by 5 parameters: the quality of your requirements, how well you explain the requirements, then how well you explain the design, then how well you made the architecture. This is the most important element. What is your architecture actually, and how it's explained. Then the last, the point number 4 is about the quality of code, so how well your product is written in whatever language you decide to use. And then final line is how well you attended your labs, or maybe how popular your product is on GitHub. So that's quite controversial topic. We'll discuss it already. So if you get 15 stars on GitHub, then you get 15 points for the fifth line. If you have 1 star, then you get 1 point. If you have more than 15 stars, then you have still 15 points. Pretty simple, but we're not gonna wait till the end because it's not really how software projects work. We're gonna ask you to demonstrate your product 2 times till the end of October. One milestone is next week on Monday. You have to present something to your TA, something. It doesn't have to be a finished project. The more it has, the better. Some requirements, some design, some architecture, some code, maybe some popularity on labs, on GitHub, sorry. And they will give you some numbers. And then on the second milestone, which is going to happen in 3 weeks from now, or 2.5 weeks, you present more elaborated, more stable product. This is how it works in industry. So in industry, in real projects, we never wait till the end. We never wait till the end of the contract. We present something to the customer in an incremental way. Remember, we spoke about this rational unified process, the RUP, which recommends us to do development incrementally and iteratively. So we don't wait till the end. We present something, no matter how bad it is. We just show to our customers what we have. We demonstrate, get some feedback from the customers. We're going to have exactly the same here, but the customer is TA, and I will also take a look. So if the project is something interesting, then the TA will show it to me. I will also pay attention, do my review, probably will correct the numbers, the marks. And in the end, we will have some sort of a competition, maybe. Not a competition, but like a list of the top projects. I will show you in our group on Telegram. I will show you which projects are the top, which projects are the most interesting. You will see them. There will be links on GitHub. All projects will be open source. So we will see what are the numbers these products are getting, and you will try to get on the top. However, in order to a little bit stimulate your progress, in order to encourage you to deliver sooner than later, rather than later, if you don't show anything on the first milestone, then you get some amount of negative points, -10. So you can still ignore it, like with the real customer. You can think, okay, I will finish everything and everything will be so great that my customer will be so impressed, so I'm not going to do it incrementally. I just wait incrementally. So I'm going to wait till the end. If you decide to go this way, then on the first milestone, you lose 10 points. The 10 points which will deduct from you at the end of the course. If you ignore the second milestone and don't show anything on the second one, then we deduct 20 points from you. So if you demonstrate something extremely great at the end of the course, you're still going to top your maximum number of points is 70. You're not going to get 80, you're not going to get 90. So we encourage you to demonstrate earlier and don't wait till the end. Pretty simple mechanism. Any questions about that? I think it's quite simple. And actually, I recommend you to think about turning your products
into something which you can use in the future and develop it better. I had one guy from your group talking to me today, and he suggested he has an idea about the product, which is a really interesting idea in my opinion. He thinks that he can turn this idea into something larger than this 2 months course. So this course is pretty short. We just meet, we talk, we discuss how products should be done, but then you continue the study, but you can make something which will stay with you for quite a long time. I gave you an example on the previous lecture yesterday. I told you about the product which I created for the interview, for the job interview. That was something I will never forget. How they asked me. I was very frustrated in the beginning. So when they ask you, when you go to the job interview, you will meet this problem actually. When you will go to job interviews, and they will, in some companies, they will ask you to do a lot of work for them. Sometimes companies even, abuse us, people looking for jobs, and they ask you to develop something, like really develop some product, some module, some piece of code, which they will use later, but they will definitely not pay you anything. They make it look like they test you, but in reality you develop something. Well, I've heard about these stories. That was not the case, but still, when you come to the job and say, I am the Java developer with 15 years of experience, and they tell you, okay, can you create a piece of software for us so we can see how good you are as a Java developer? That's a little bit offensive sometimes. Well, for me it was. But then I thought, okay, how about I turn this situation for my own benefit? So instead of working for them, instead of spending my time and making the product for them, for the potential employer, instead I will make something which will be good for me. So it's going to be open source, it's going to be in my portfolio, and it will be a product which will help some customers, some people who will use it, and I will get some traction. And I'm telling you, it's still in the market, still popular. I have thousands of users there, traffic, everything goes. It's called if you can Google it, S3, the S3 AUTH, S3 OS. That's my piece of software, which is open source and which is, I'm probably 8 years old or something. That was my interview job assignment. So again, encourage you to do the same. Don't do anything which is going to be wasted tomorrow. That's my recommendation, your lifetime recommendation. So every time anybody asks you, your employer, your temporary employer, your teacher, anybody will ask you to do something, to do something for them, to whatever. It should be something which will stay with you. So invest into yourself. Don't develop anything which will be wasted, you will throw away. Don't make temporary code. Every time when you develop something, think about how it's going to stay with you. Turn it into an open source product, turn it into a library, turn it into a framework. But never do something which you do and then you kill it and then you move on. So with time, which you will spend probably, let's say, in the next 10 years developing software, 15 years, after 10 or 15 years, you will look back and you will see, oh, I have, 50 different products, 50 different libraries, frameworks, something. That will be your portfolio. That will be much more valuable than any resume, any CV you can build. It will be much more important for your potential employer if they see that this person has 50 different products created over the last 15 years. So start now. Okay, that was an intro. And now let's talk about data formats, specifically XML. And I will compare it with JSON, YAML, TOML, whatever. We'll talk about the family of products, family of data products.
Can I ask you a question?
Yeah, ask me a question.
So it's not related, it's related to the course in general. So I noticed that some topics are changing. So is it possible, for example, like this is a suggestion for a topic. So usually when we see open source codes on GitHub, there are lots of types of files. For example, here we are mentioning XML, JSON, but there are also, like for example, license.txt, .env, .yml, and so on. So,
right.
Will these kinds of files also like
the structure, you want to discuss the structure of open source repositories?
Yeah, like for example, they always exist in this repository.
So okay, the question is, will we have a lecture about open source development and the structure of open source repositories, so how they should be structured? That's a very interesting question, even though We didn't plan that, but probably we should. Maybe I can say a few words in the end of this lecture, because we probably can talk about this. Who of you actually is interested in becoming open source contributor? In developing something in open source? 1, 2, 3, probably everybody. That's good, you should be. Actually, I believe that open source is the future, is the only future we have. I think that now we are somewhere in the middle, switching from proprietary development, like it was for decades. We were developing software mostly for the companies, mostly for their internal repositories, but we're moving to the time when development will happen in open source mostly. So we will develop products for open source, and then companies will charge money from users for services, for servers, for data transfers, for traffic, for something like this, but not for the software. So the software will be open, everything will be open, starting from Microsoft Windows, including enterprise editions, ending to large databases like Oracle. Everything will be open because it will be beneficial for companies to have their products in open source. So when you graduate and when you get to the market, if you have no experience of making open source, your value will be lower comparing to people who come to the market, come to employers, and say, I am the contributor to 1, 2, 3, 4 open source repositories. So I'm not just a good Java developer. I'm a contributor into Apache library or Google Guava library, whatever. In this case, your value is much higher comparing to somebody who just says, I'm a good programmer, just 2 good programmers, 2 good Java engineers. But if you are an open source, and being an open source means way more than just knowing how to write code. So staying in open source, that was a good question. So how the repository is structured? This question will not be answered in any Java book or any Python book. Read no matter how many Java books or Python books or Go books you're going to read, nobody will tell you how to structure open source repository, how to answer the questions coming from the community, how to respond to pull requests, how to accept them, how to reject, how to configure continuous integration on GitHub. These questions are not possible to answer. To answer in the book. So no books will give you this knowledge. And actually, it's hard to find those knowledge even on the internet. It's hard to find it on, which one? Sorry, yes, it's turned off. Thank you. So it's hard to find those answers even on Google. So you can only get this knowledge, only get this experience by doing things, by developing code. So the sooner you get to open source, how you can get there? There are only 2 ways. The first one is you make your own product, and then you start from zero, and then you start everything, and then you try to learn everything from the ground level, or you join someone else's product. So you find an interesting open source project, which is developed on the language which you like Python, so find Python project, join this project and start making contributions. So think about what you can give them, submit them pull requests, fix their code, write some unit tests for them, improve their code, fix some typos. So work with the code. They will start accepting your pull requests eventually. Initially, they of course will reject them because they will be of low quality. That's normal. But the more you submit, the more you try, the higher will be your reputation. The more stars you're going to get on GitHub, the more followers, the more reputation, and eventually you will know how it works. You will understand open source territory. And then you can, like I said, you're going to get a better job. One of the most popular question, I quite often, record some videos on YouTube. I speak publicly sometimes, and very often people write me questions under the videos, under the blog posts. And one of the most popular questions after the videos, when I ask them what kind of questions you have for me, what would you like me to answer you, the main question is how to become a programmer who gets 500,000 rubles a month. It's like the main question, most important, most popular question, like how to get there, how can I get 500,000, which is quite a big salary right now in Russia. And my answer to this is that you need to bring together with your portfolio, something that very few people have. So you have to stand out. You have to be different than everybody else. If you're just good Java programmer, there's a quite low limit of the potential salary they're gonna pay you. If you're just good Python programmer, no matter how good you are, there's a limitation because all of the people, they claim to be good Java or Python programmers. Very few people will say, you know, I'm just a beginner. Well, after the graduation, if you graduate, you come to the company and you say, I am a junior programmer or I am middle-level programmer, but there are other junior programmers standing in the line. And you just stay in the line with everybody else. And the question is, okay, why do we pay you 2 times more than everybody else? What's the reason? And you have to give them the reason. And one of the reasons you can say, I am an open source contributor, which is now on the market is not a very common feature of a programmer. So most people cannot say that they are open source contributors. Most people will say, no, I have very, very little, even senior developers. When we hire programmers to our lab, we ask this question, like, what's your experience on open source? And in most cases, the answer is, I didn't have time for that. I know how it works, of course, no problem, I can contribute, but I didn't have time. So I have no GitHub account, I have no experience there. And in this case, the price just, boom, you get the average. No matter how much you tell us about yourself, how great you are, how much you know this Java, C++, whatever, boom, you're just like average programmer. If you're saying that I'm the contributor, an active contributor to Linux core, then it's a completely different story. You're not just a C programmer, C++, you're just, boom, a different league of programmers. You're like one of the elite programmers in the world, so we're gonna pay you 2 times more than everybody else. That's how it works. For most corporations now, for most companies. So I suggest you to start thinking now. You cannot get it in 1 day, you cannot get it in a year. You will need probably, I believe, 3 years to get to the open source market. 3-4 years, something like this. In 3 years, you will have some good account on GitHub, good reputation. You will be in some projects. You will have some own repositories. Some of your products will have like, I don't know, a few hundred stars. You will be ready to say, I'm active open source contributor here and there. Make sense? Think about this. Now it's the right time to think. Because it's difficult to think about this when you are 35 years old. That's kind of, too late. Yeah, 1 second. That will be just a little bit too late because you will be lazy, you will have like a large family, you will be like, come on, I'm gonna just, refurbish my house instead of repaint my house because open source actually is extra, as they say, extra curriculum activities. So usually you do it outside of your main work, outside of your regular job, outside of your study. But now you have an opportunity to do it together with the study. So I'm giving you an assignment, you have to complete this assignment. So this is an opportunity to catch it and say, well, great, I'm gonna do it open source because I combine these 2 activities. I need something to do for this teacher, for this course, and at the same time, I make it open source. And I make it nice. I make it look nice. So it's gonna be a nice, good looking product. So great, you exit this course in like 1.5 months or what we have, 2 months left. So you exit this course with the product in your hands. The question.
Yeah, the question is, what do employers think about you as an open source developer? Because you usually need to spend some time writing some open source applications and actively contributing to them. So don't employers think that you're going to be wasting too much time on something you're an active member of?
Yeah, that's a good question, so I'll repeat it. So what employers will think if you say I'm an active contributor to Linux core, and then we hire you, and then you probably will continue doing that instead of doing our projects. You will continue staying on Linux and contributing to them. That was the mentality probably 5 or 10, maybe 10 years ago. Exactly like that, employers, maybe even 5 years ago. But now the situation is changing dramatically. I can just see it right now. I saw probably 3 years ago, that was exactly very close, that was the reaction of employers. Like the question was like, you're doing so many open source products, so we are more interested in people who will work for us, who will work for our products. But now they realize that most of our products are open source. So most of the products, for example, in our lab, when I work right now in Huawei, we have most of our products, which we do in the house, in the lab, they're open source. So we do products which already are open source during the development, even during the development. Of course, we have proprietary software in Huawei. It's a large corporation. We have a lot of proprietary software, but we start moving into the direction of open source, where developers, in most cases, do open source instead of, in most cases, doing proprietary code. So that's what I'm saying. So we are switching horses right now. And when you graduate, when you start being senior developer, which is going to happen in probably like 5 years. So in 5 years, the world will be different, completely different. The companies will just be interested mostly in open source development. Only small parts of the software will be proprietary software. Most stuff will be done in open code. And you will be right on time in this moment. Okay, enough with the intro. Let's talk about XML. So XML. So we'll talk about extensible markup language. Who doesn't know what is XML? I believe everybody. Yeah? Somebody? Then we will talk about XSD, XPath, XSLT, XQuery. Who knows what is XSD? You see, that's a different question. One person. So we all know about XML, but very few people know what is XSD. But they go together, and we need to know them both. Then we will talk about JSON. I'm sure everybody knows JSON, right? It's even more popular than XML right now. Then we'll talk about these formats, YAML, TOML. Who knows CSV? CSV. Oh, everybody. That's great. Still very popular. And then we're going to talk like usually. I'll give you some books, some venues to publish, and then some call to action. First, extensible markup language. This is the example of the document in XML. We call it a library. So the first line says that's a preamble. It says that this document is XML, and then goes the element. The element is called, like I call it, library. So the library is the name of the element. I think everybody understands what's there, or not? Do I need to explain what's on the picture, step by step, item by item? The library is the element which opens and then closes with the closing tag. So the opening tag, it starts with this, how would you call them? Brackets? They're not brackets. The angle brackets, right. So they're enclosed in these angle brackets. The name of the element is library. And then it starts on top, it finishes at the bottom. So the whole thing is one element. And then the element may have sub-elements. It's just a text document. So you open it in a text editor. So nothing special. It starts with the first line. It's a preamble. It starts with this angle bracket and then the question mark. After the question mark goes the name, XML. And then you can list version, encoding, and some other things if you need them. Version is 1.0. Encoding is Unicode. Who knows what is UTF and why it's different from UTF-16? UTF-8, UTF-16. One person, two people, three people, four. I highly recommend that you read about Unicode on Wikipedia. It's not hard. It's very easy. So Unicode is something you definitely need to understand as a programmer. Unicode. The idea is simple. So many years ago, computers were invented. And all information in computers was stored in bytes. And each byte was, no, not in bytes.
Yeah, but it was stored in watts, because they were different sizes, 12 bits, 7 bits.
Yeah, that was, right. It started with words, and words were different lengths. So word was word of what? Word of bits. So the bit was the smallest element of information, which is 0 or 1, and then they started to make words, and words were of different lengths. When I'm talking a time which is a bit later than that, so when bytes actually showed up and computers were more and more like standardized and bytes were more or less everywhere, so I'm talking about personal computers, and the question was, how do we present the information in different languages? So in one byte, which is 8 bits, we can place only 256 different values. And for the English language and all the symbols. So it was necessary to invent some mechanism how to present in 1 byte, how to show something which is not English letters, because English letters and all the symbols, they can perfectly fit into probably 100, it's enough 100 options to present them. But if you want to be like, for example, Russian language, then you need more than 100. You need 100 for English, and then we still have about 150 or something for some extra symbols. And people started to use different, not only Russian language, Chinese language, for example, Japanese, there's all different symbols which they needed. So they started to use, to improvise how to present this stuff into a very limited, capacity, which is 256 possible values. So eventually there were the whole mess with the encodings. So they were calling that encodings. For Russian language, there was one encoding. So when I send you the data, and it's, for example, I want to say the letter, the letter X, the letter, whatever, Russian letter, for example. So I used the symbol by the number 145. When I send it from my computer, in my screen understands that 145 is the Russian letter. When it comes to your computer, it's still 145. And your computer has to interpret it and show me the Russian letter. So all computers knew that, for example, the letter 65 is the English A, the capital A, English, 65. All computers in the world knew about that. But all computers were different about what is 146. One computer was thinking that's a Russian letter, this. Another computer was thinking that's a Chinese letter or something. Another one was thinking differently. So these old computers, they had different encodings. That's the name, encoding. So what encoding your computer uses, it depends how you show me the text. And that was always a problem. Like I type my text, I type, for example, Russian text on my computer using one encoding. So all the letters are being encoded in one set of numbers. Then I send you the document, you open this document, and it looks completely different. So you need to do encoding to encoding. So you need to convert one encoding to another one. There was a whole mess of programs, the big variety of programs which were converting from one encoding to another encoding. I remember that time. And then Unicode was invented. The Unicode is the idea was that we all gonna use the same encoding for huge amount of symbols, and the encoding will be unified. That's why Unicode, unified between all computers. And Unicode works in a number of bytes. So with Unicode, you can present, if it's a simple, for example, English letter, then it's still 1 byte. But if you want to show like Russian letter, then you're going to use 2 bytes, and sometimes 3 bytes, and sometimes even 4 bytes. So Unicode is made like this, that different symbols, from Chinese symbols to Russian symbols to like the huge variety of symbols, there's question marks, emojis, many things. They're all together. They stay together in this huge list of Unicode symbols. And in order to present them, we usually use at least 1 byte, but sometimes 2, sometimes 3, and even sometimes 4. So together we can have like many symbols in this encoding. So if you, by definition, by default, XML is the format which uses Unicode. So saying on the top of the document encoding UTF-8, it's not necessary. So we can just remove it because this is the default encoding. If there is a special case, so we need some different encoding, then we can configure. But usually this is not necessary. So again, I don't have time now to explain you everything about Unicode, but you definitely need to read about this. That's the subject which will help you understand programming much better. So next we go to the elements. So one element, another element, the library. Inside we have the book. So it's more or less hierarchical, not more or less, but it's a hierarchy. The XML is the hierarchy of elements. Library, book, author. Library, another one, book with the ID 42, with the ID 43. You see that the ID 43 stays in the double quotes, the ID 43 stays in the single quotes. You understand probably the difference. There is no difference. You can use double quotes and you can use single quotes. Absolutely no difference. I just showed to you so you understand the difference. XML has attributes and elements. There are 2 things. Attribute is like ID, element is like with these angle brackets. So there are, they say, 2 dimensions of XML document. On one dimension we have elements, on another dimension we have attributes, and they can stay together with each other. Sometimes people say that we only have to use elements. Some people say we should use more and more attributes. Some people use them both. There is no clear rule about this, but I suggest the rule that elements are for the data and attributes are for the metadata. In this case, it's hard to say what is metadata, what is data, but for example, the book, so I'm saying in this case, the logic was this. The book has an author, has a title, which is something for the user, for the meaning of the book, but ID is something internal. It's an information which is internal, which users and people not interested in. So ID, that's why I made it an attribute, everything else is an XML. Pretty simple. So I suggest you think about how XML can be used in your applications more and more. I'll show you a few things which also exist in XML, which you need to understand. Namespaces. Namespace is, take a look, it's still the same document, the library, but library has now 3 attributes. The first one is called XML and S. The second one is XML and S semicolon A, and then XML and S semicolon T. So this is like the definition of namespaces. So the namespace has a URL, URI actually, universal resource identifier, some unique identifier of the resource in the entire global net and internet. And then inside the document it has the prefix which identifies this scope. So basically we have a book, and then for the book we want to add, for example, some information which is relevant only to specific domain. So let's say this book, we're trying to present as much information as possible about the book. So we say, okay, the book has an author, has a title, and also the book has an identifier on Amazon. And Amazon, they have DP, I don't know what it means, like something product ID or something, DP. So this DP is the unique ID of the book on Amazon. So I don't want it to stay together with the author and the title, because this DP is relevant only to the domain of Amazon. So we make this identifier, which is called namespace, and then we can attach our attributes and our elements to this specific namespace. So in this case, we have some sort of a multi-layers in the same document. So first layer is the default namespace. We have title, author, and the book. And then another layer, we say, okay, now we're going to have some information which is Amazon related. So we add like an extra layer, which technically, lexically stays together with the elements of the main layer, but they are prefixed. Then we have another layer, which is related to Twitter. So for Twitter, we give, for example, the Twitter ID of the author. So it's another extra layer. And the document can have multiple layers like this. So each namespace gives us an ability to introduce extra layers for the document. Makes the documentation quite powerful. For example, you have the document which is full of information, and then you come in and say, now I want to add something extra which will be understood only for this API, only by this software. So when the software will parse this document, the software doesn't need to see all the title and the author. The software is only interested in Twitter names. So the software just gets in and says, filter out everything which is not in my namespace. So I only want to see my layer. So it's like a slice through the document. Quite powerful technique. Next one is escaping, something that you need to know about XML as well. Escaping means, take a look at the Fibonacci's number. So instead of placing the apostrophe there, I cannot do that because I open the name of the value of the attribute title for the element F. I open with the apostrophe and then I finish it with the same apostrophe. So I cannot use it again inside. I need to somehow escape it. You probably know how it works in programming languages when you escape with the slash or you escape somehow else. Here we have special symbols, special syntax for that. So you put the ampersand, then the name of the element, and then semicolon. That's how it should be. So you must escape inside the values of the attributes. You must escape inside the value of the element, just like this document demonstrates. Sometimes people get into trouble if they don't escape, because especially with large documents. So you need to understand that XML, even though it's quite text, it looks like plain text. You don't need any special editor to edit it. and it's actually a good practice to edit it with the simple text editor. But remember that you just cannot use whatever you want in this document. You have to escape. I think there are 5 or 6 symbols which must be escaped. It's the opening angle bracket, the closing one, the double quote, the single quote, and then I think a few Unicode characters. So you must escape like a few symbols from Unicode which are not printable, not visible. Like the symbol with the code 0, I think it has to be written like this. So I think that XML right now is not one of the most, but the most, way more popular than any other formats for representing data and for exchanging data. For example, this is the list of standards which are based on XML. For example, SOAP. Who knows about SOAP? We will talk about this in a few lectures. SOAP is the protocol to exchange data between microservices, between servers, not necessarily microservices. Between servers, SOAP, that's very old protocol. RSS, who knows RSS? That's for news reading. Yeah, the RSS is based on XML as well. Atom, it's like the more replacement of RSS. SVG, do you know SVG? It's for pictures, right? So SVG inside is an XML. So SVG is a vector format for presenting images on the internet. The internet is very extensively use SVG because it's vector format. What it's based on, it's XML. So if you open SVG image, then you will see XML inside. So we can go to Google right now and type, flower in vector. You will see the images. You can click the first one, the flower in vector. But definitely the image will be SVG. So download the SVG, click open the file, open it with any editor you have, and you will see XML there. So it's vector format, which is explained in XML. Without XML, it would not exist. HTML5, XHTML, those are formats also XML. So if you design your web page, now it's highly recommended to make it HTML5. This is the standard which is based on XML. So if you design an HTML5, your document will be, formatted the way XML has to be formatted. OpenOffice XML. I don't know. I haven't seen it, but I'm sure it's XML. So the documentation which we exchange, like documents, like spreadsheets, presentations, they're all XML. For example, PPTX, DocX. This X letter at the end, it means XML. So Microsoft Word document, inside, it's an XML document, I believe, if I'm not mistaken. And some other formats. And then I put the smile here because this XMIR format, XMIR, which we invented in our programming language, we use it as an intermediate representation. So we also use XML to represent the syntax, the grammar of a programming language. So I give you the link to wiki page which lists all or most standards which are based on XML. You will probably, when you will start making your products, when you go to start working for money, then most probably you will need to, at one point of time, invent your own format for exchanging of data. So there will be tasks where you will have to get the data from one system, send to another system, and then let it happen over the internet. So the question will be, what's going to be the format? So how you package this data? If you have, for example, 2 microservices and you want in one microservice something is being rendered, in another microservice something being prepared, like data. So how do you interconnect them? There will be a number of options, and one option will be to invent your own format. XML will be your choice number 1, I think. Well, there will be other choices because XML is quite verbose, it's quite long. So if you want the data to be fast, if you want, for example, to send, look at this document, like how much data we have there and how much metadata. So the real data is like the title of the book, 20 characters, the name of the author, 20 characters, the name of the Twitter account, 20, and then the ID of the book, another ID of the book. It's another 20. So how much? It's like less than 100. But the total size of the document will be like 300 characters. So XML is very, it has too much on top of the data. But it's very convenient because it's readable by people. So you can easily intercept your interaction between these two servers and check what's going on by just looking at the documentation. If you use something else like binary format, for example, if you package everything in a binary form, then it will be much harder for you to understand what's going on by just intercepting the call and reading the traffic and checking the data which is flowing. So binary format is much faster because it will be just binary data, but much less readable. Okay, so now the more interesting and more tricky part, because I believe that everything I said before you knew, even without me. And now interesting parts which make the family of XML standards are very interesting, and not so many people understand that. So in my experience, when I work with people in the industry, when I work with programmers, all they know about XML is that XML is worse than JSON. That's the only knowledge people have. So when I say XML, they just, oh, XML, no, JSON is the future. JSON is what we love. But this is not true. XML is much more powerful set of standards and set like a family of standards, which can be very useful in your product. For example,
So before we continue with the I just want to understand the real purpose of XML.
the real purpose. Why do we need XML? It's the format to exchange data, yes, basically. For example, to make a picture. So how do you make the vector picture? So I draw the flower, and I need to send you the flower. So how I format this flower in a file? That's the question. So if you're the programmer, imagine you're the programmer, I draw the flower with my pen, so I write like a circle, a circle, a circle, paint it with the green color, something with the yellow flower, and now you need to save it to the disk. Not pixel by pixel, because this is not a raster image. You need to save it as a vector. So how would you save it? A circle, and then the area, and then the line. So those are elements on the image. That's why it's vector image. So you need to invent some format of how this file will be formatted. So you take XML, and XML just say, okay, make an element, make sub-element, 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 hierarchy of structures. So you make an element circle, element line, element area, blah, 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 blah. So it's very simple. XML is not, there's nothing in XML which says something about flowers or circles. It only says that we have elements, we have attributes, we have namespaces, and they have to be formatted like this. That's all. What kind of elements you're going to invent? It's going to be library, or it's going to be the book, it's going to be the title, the author, or circle, or line, or color, or area. It's up to us. XML is very simple format. If you read about XML, it's probably going to take, I don't know, a number of pages, and that's it. Because there's not so much to talk about. But XML, sorry, that's a typo, it's not XSM, XML. XML schema definition. XML schema definition is the document which says what may happen in the XML document. So this is the schema definition for our library document. So we have a library in XML, and then we make a file called library.xsd, schema. In this schema we have the book may only have one author. The book may only have one title. And the book may have an ID. So it's like a schema. It's like we just explain the format. We explain what may happen in the document. For example, take a look at the bottom of this. It says complex type. It says the element name library. The next thing should be indented a little bit right. Again, the typo. So we take the element by the name library, and we say that inside this element we may have a number of elements. There's so many typos in this file. I made it right. I made it wrong. So we're saying that we may have only the library element, and then inside we have a sequence of books. Book, 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 book. Nothing else may happen there. So inside the library, we may have a sequence of books. That's what this schema is saying. So when you receive what the schema is used for, when you receive a file from somebody, and the file says it's a library.xml, you take the schema, which usually is a public document. So usually what they say, okay, My library has to be formatted like this schema is saying, and I publish this file somewhere on web. So it's a public file on web, and I say, this is the schema of my document. The library comes in to me from you, from your web service. I take it, and before I parse it, before I start getting the data out of the document, I take the schema and I compare with a special analyzer. In all programming languages they exist. So you apply the schema and you check whether there are any mistakes, violations. And this validator will tell you, the schema validator will say, no, no violations. So everything is formatted just like it should be. And then you start processing the data. So it's a very powerful instrument which will prevent the errors, which is like a testing, like a runtime test. So every time the document flies in, you will have an ability to check it against your schema. So usually people, when they design, for example, a web service, I mean good programmers, they say, okay, our interface is XML. This is how the XML should look. This is the schema, which you can use to check your documents before sending to us. And we will use the same document to check the documents which come to us before we actually process them. That's one thing. Another thing, do you have any questions about this XSD? Do you understand the purpose? More or less. It's like, I would compare it with, I don't even know, what? Regular expressions, for example, yeah.
IDE, we can import from XML to what even the user they customize by themselves to check the code.
In IDE, we have XML. Yeah, for example, it's like a checking of the, yeah, let's say it's a, like a grammar checking. Yes, grammar, exactly. It's like checking the grammar of XML.
Kevin, is it, as from my understanding, is it that XSD gives like the rules of the data we should have?
Yes, it's the rules about the data. Exactly. XML is the data and XSD the rules about the data. Exactly, yes. So XSD says how your data should look. So you cannot just do whatever. Because, well, you can, but in this case my software will break. If you structure it differently, for example, in the book you will say not title and author, but you will say titles and authors by mistake, because you misunderstand the documentation. And you send it to me. I'll start parsing the document, and it breaks in some runtime. I can, of course, while parsing, always check, okay, the book, does it have the title? Does it have the author? But that will make my Java code super long. I will say, if no title, throw an exception. If no author, throw an exception. If. So before I start really dealing with the data, I will have to do a lot of manual checks, like if. We remove all of that, and we just make an XSD document, and it checks everything, just like regular expressions. You can say, for example, my text should start with the capital letter, capital English letter, then should go the space, and after the space should be the number, and then after the number should be another space. How long is going to be your Java code, which will check that your string, the text, starts with this? I don't know, 5, 6 lines of code, 7 maybe even longer. With the regular expression, it's going to be, well, in Python, 1 line. In Java, maybe like 2 lines. The same for XSD. How long is going to be the code which will check everything? Like a long XML document comes in, we need to check that everything is clean. We're going to write like 2 pages of checking, 2 pages of Java code to check it. With the XSD, it's going to be 2, 3 lines. The second very convenient element of XML family of standards is XPath. Who knows about XPath? Also very, very, very important tool which you need to know. On the top, right under the title, we see the document. I made it more compact in order to put everything on the screen. So it's our library. In the XML document, you can put spaces any way you want. So this is more compressed format of the same document we had. So I start with the library, then goes the book, then goes the author, David West, and then I just close the elements, which is not correct. So it should be /author/book/library. But I made it like this just in order to make it more compact and fit into the screen. So it's not grammatically correct. And then goes 5 different XPath expressions. So XPath is like a language, declarative language. The declarative language which says all of these 5 lines says the same. They return the same. they basically tell you that using this locator, using this address, they call it XPath or pass or address, find me what you can find in this XML document which matches this path. Take a look at the first one, /library/book, and the square brackets at ID equals to 42. What does it mean? Can you explain? What it's going to find? I mean, what's the logic of this expression?
Goes to the element, library, or component, like
Element.
goes to element library that inside of it there is element book, and for this book there's attribute ID which is not 42, just fits.
That's right. So what it works, I will a little bit refine your definition. So what it works, first operator, probably it's an operator, slash. Slash means the root element of the entire XML, the root. Then we say library. Library means find me all elements which are titled library, because there could be many of them. Library. So find me all well, in case of the root, it could be only one. So it says root library, find me one element, well, find me the element which is at the root and its name is library. It finds me the element. Then I go deeper onto the lower level and find me all books, all elements with the name book. It finds me 2 books. Well, in this case it's 1, but it finds me all books. And then I refine my search with a square bracket and I say, on all the books you found, pick only those which satisfy the expression inside the square brackets. And the expression could be, for example, attribute ID is equal to 42. So it will find me the book with the ID 42. The second expression, the second, //book, // means anywhere on the hierarchy. So look at the document and anywhere, find me the element titled book with the element by the name book. Yeah. Anywhere, any level, just find an any level on the document, no matter where, on the top, the bottom, anywhere. So find me, first of all, find me /book, all books, and then no matter how many of them you found, it's like a database search, refine my search with the expression inside the square brackets. And the expression is ID equals to 42. So it's like a SQL request, you can probably say it. It's like refinement the request with these square brackets. The second example, the third one, /book, again, find me any book you can find in the document, and then take the first one. So first is a predicate, which will be executed on each book you found. So you find me all books, it's going to be the list of books, and then go through 1, 2, 3, all of them, one by one, and execute the function first. Of course, only on the first one is going to be true, everybody else will say false, 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 false. So in this case, it will find all books, which is just one in this document, and the first one will be picked up. The second one is book. In this case, we select not by the attribute, by the author. So we say, find me all the books, and then pick one where the author equals to something. And then the final one, which is tricky, more interesting. In this case, we say, find me all the books. Then, from all the books you found, select me the book which has an author, which text is equal to David West. So you can include those expressions one into another. So you're saying in this case, find me the book which has an author, which has something, which it could be which, etc., etc. So it's very powerful declarative language. Using which, you can do anything you want with the XML document in a declarative way. So you don't need to write in Java for loops through the elements, if it equals to something, then go into deeper level, if it equals to something, go to... So all the mechanism of traversing through the document and finding the information in XML could be automated with a very simple, easy to remember and understand XPath expressions. So for example, you say, my API expects XML documents. So send me the XML document. They send you the huge, large XML document, and you, using XPath inside your Java, Python, or Ruby code, or whatever code, all programming languages, they have this. You just say, okay, from this document, I need how many books they're sending to me. You just say // count books. well, you can read about the syntax. You can count, you can summarize, you can do whatever you want with this language. You can count, then you can fetch the information from there, any possible traversing and any possible selection through XML document. So first step, you check your document using XSD. Second step, you find any information you want using XPath.
Questions?
Yeah, good.
First question is why with some of them, for example, we have book at ID, not ID. It's
Because, yeah, it's a good question. Why? And sometimes we have at ID and the author doesn't have at. Because ID is an attribute and author is the element inside element. So author is the sub-element. ID is an attribute. Remember we talked about that. Look at the syntax. ID stays inside those angle brackets. Elements, they go like sub-elements. So ID is like meta information and elements are like, you know, normal, like kids, children.
why don't we write book slash author?
Why don't we write book slash?
Can we write book slash author instead of book brackets author?
Yeah, we can write book author, but in this case it's going to find us an author. But I want to find a book. So every XPath expression returns you something. It could return you elements, books. It could be returns you authors. It could returns you a list of IDs. So each time XPath expression returns you a list. The result of XPath is a list of something. It could be a list of elements or it could be a list of attributes. It could be a list of comments. It could be a list of something. A list of some XML, you know, nodes, they call it. Nodes or attributes, I'm not sure exactly.
Does XML have data types like strings, integers, and so on?
Do we have data types in XML? We have data types. We have special XSD schema which defines types. So if you want your document to have types, for example, you want ID to be numbers only. So you get the special XSD schema which has many types: string, ID, numbers, integer, float, and everything. And then you attach this schema, not attach, but you mention this XSD schema for your document and say, in this document, you know, using the schema you can restrict your types. So XML by definition have no types, nothing. It's just plain text. I mean, text everywhere. But then using the schema you can introduce types to your documents. Yeah.
So how do they apply that XPath and XSD to XML libraries for that?
Yeah, how to use it practically, yeah? So in each programming language, what's your programming language? Python. Python, right? So in Python, you just Google XPath in Python, you will find tons of, not tons, but you have like main library, which will allow you to do this. So first step is to get the document get the text from input stream or something, then make the XML document. Python will help you to do this. So you will get an object, which is XML object. And then on this object, probably you'll have a method, which is called XPath or find or something like this. And then you provide this expression and see what it returns. Just play with it. It's going to be 3 lines of code in Python. Get the text, parse it, make it XML, and then on the XML object, you run XPath expression using the method. It's going to be 3 lines of code. And see what it returns, printed, and that will be the good start. Then we will understand everything. In Java, it's much longer. In Java, the same will take like 10 lines of code. It's more complicated. In Ruby, Python, Go, it's 1 line, 2 lines. In PHP, who writes in PHP, by the way? Nobody, okay. And Go? Anybody on Go? So you all Python guys, huh? No? What else besides Python? Java? Who writes Java? Oh, that's good. Plus 10 points, yeah. Because I was thinking nobody writes Java here, so that's good. And anybody C, C++? Really? Like for real projects? Yeah? Or just playing with it? Real stuff. Yeah? Okay. Anybody with Rust? Try Rust. Yeah, okay. Next one, my favorite. It's called XSL transformations. That's the beauty. That's a super, extremely powerful tool, in my opinion. XSL is basically a language, a functional programming language, by the way. not procedural, not object-oriented, but functional programming language, purely immutable, perfectly designed in my opinion, absolutely extremely difficult to understand for newbies. You will spend like a few years to become an expert in this stuff. I spent 10 and I'm far away from being an expert. What it does, it takes one XML document, and then using this language, you explain how you translate, how you transfer this XML document to something else, to another XML document. So you can take, for example, a picture, an SVG, and make a different picture. Just restructure the XML document. You can take XML document from here and make HTML page. You can take the data from the database, turn it into XML, and then from XML, you using XSL programming language, you turn it into HTML for a user. So instead of taking the data from the database and then using Java, put this information into HTML, you just take it from the database, make XML, send it to you, and then using just one simple language, like one simple script in this programming language, you just boom, make HTML.
How simple?
How simple it is. Well, it is, in the beginning, it will be super difficult in the beginning, because it's not only functional, it's, first of all, it's deeply, deeply functional. So for example, there are no for looping. There's no loops. You cannot loop, only recursion. Everything's through recursion. So you cannot just iterate over anything. You cannot say, the iteration is probably the hardest problem to solve. So no iteration. Everything has to be recursive. You know what is recursion, right? Yeah. So everything has to be recursive. No, nothing else there. And it's quite hard to debug. So I'm not sure there are debuggers. Well, maybe they exist, maybe in IDE. But if you understand how it works, for example, I told you the last time about new programming language which we designed, EOLang. So EOLang compiler is written entirely in this programming language, in XSLT. So what do? We read the syntax of the language using the normal syntax parser. Then we turn it into XML. So in XML, we build this abstract syntax tree. So everything which is we understand from the language, we make an XML. And then from XML, we apply XSL transformation I'm pretty sure about 30 times. We have 30 different XSL pages. So we translate it to one again. We check the syntax with the language. We check the grammar. Every time there's XSL, we have many XSL, this is called style sheets. So we apply these XSL scripts on top of the original XML file. And every time we change a little bit the original document. So it's not necessarily, this XSL not necessarily will turn your original document into a new one. It can just modify your document. So you take your XML, for example, you want to, let's say you have an XML document and you have these titles of the books, and you want to capitalize all titles. How would you do this? You make an XSL. You take original XML, apply the XSL, and you make a new XML. And the new XML, all titles will be capitalized if you write your XSL right. So in our EOLang, we have about 30 different transformations. And in the end, the last transformation takes XML and makes Java. So it takes XML, like language description of the program, and then converts it to text. Not even to XML, but to text. And in the end, we have Java. So that's how a compiler works. So it's an extremely powerful technique.
Why 30 sheets? Why 2 layers? Why not 1 layer?
Why 30 instead of 1? Because it gives us more flexibility, because every style sheet makes a very small change in the XML document, which is more traceable. So I can see what's going on. I can trace how they modify the document. I can say, okay, this is my XML, the source one. I can see the modification. Okay, just titles were capitalized. The next one, how about we, extend the list of authors. The next one, how about we add Twitter IDs to all the authors. The next one, how about we add Amazon IDs to all the books. 5 different transformations. And each transformation is traceable because I can see intermediate results. I can see these XML files which are being generated on each step. It makes the whole pipeline very traceable. This is what XSL is for. Try it out. Unfortunately, this programming language, this style sheet is becoming less popular now, unfortunately. So it was very popular. I mean, not very, but it was, the hype was like 15 years ago, maybe, I don't know, 12 years ago. But now most people just, no, first of all, XML is in trouble. Most people are moving to JSON, unfortunately. They believe that JSON is just more fun, more geeky, more for hackers because it's primitive, simple, but I believe it's more for primitive tasks, not for all tasks. So XML is still, I think, irreplaceable format. It's extremely powerful because of these tools, not by itself. By itself, XML is quite simple, but because we have these tools, everything is so powerful. So a few words about JavaScript object notation. That's why JSON. JSON is originally JavaScript object notation. Probably you know about this. So how it's being originally used. So let's first of all take a look at the example. JSON for the same library. So in JSON we have an array. We have the list of libraries. So each list of books. So each book is the array. So it has the ID, author, title, etc., etc. JSON doesn't have attributes. Doesn't have net namespaces. Doesn't have nothing. Doesn't have schema, doesn't have XPath. Well, they have something like schema for JSON. Probably you can Google JSON schema, you will find something. They have something like XPath. You can Google JSON XPath. They will have some hybrid solutions. So something exists for sure. About XSL, I'm not sure. I don't think anything like this exists, but you can try to Google. So JSON is perfect when you need something super primitive. You don't need to ever check the validity of this. You don't ever need to extend it. If you need to exchange 1-2 pieces of information. Why it's so convenient? Because it's possible to do this in JavaScript. I'm sure you know what it is. So basically these two operations made JSON super popular at the time of AJAX. Who ever heard about AJAX? AJAX. So you know this story. That was asynchronous JavaScript JavaScript exchange, I think. Asynchronous JavaScript exchange, AJAX. So that was the movement, I don't know how many years ago, 15 years ago, when we were building websites. They started to build websites with the JavaScript. That was the time when it became technically possible. So it was possible to download the HTML page. Inside the HTML page, put the JavaScript, and then JavaScript was connecting back to the server, taking some data, getting back this data to the HTML page, and showing it for you. For example, when you when you open Facebook page, it's exactly what's happening. This AJAX. So you open the the Facebook page. It loads. You see the page, but it's not complete. So it starts downloading the pieces from the server. So it downloads these pieces, and in most cases, that was the idea, to download these pieces in JSON format. Not XML, but JSON. Why it was so convenient? Because it's possible to do exactly like the first line is saying. So you go to the server, you download the object, and then you say json.parse. And everything that comes from there immediately becomes an object in JavaScript. So you turn your document into an object with just one line. That was the beauty of this mechanism. And you can turn it back. You can say JSON stringify, then give the object, and it will make it a JSON. So you can send JSON to the server and get it from the server. Every time compressing this from the object to the string, from the string to the object in just one line. Simple as that. Good? Good.
So the object would have more size than the string, or what is it? What's the point?
I'm not sure about the size. Well, of course, the string will be... we can't really measure the size of an object. We don't know how big it is. It depends on the implementation of JavaScript at the runtime. But in terms of string, they're more or less the same. So the string, for example, this object, age25. So you take it, the string age25, you convert it into the object, so it's going to be the object with the one attribute, age, and the value 25. That's all.
And what is the point exactly that if you get the JSON as like just a text file, then you parse it later, it will be faster?
You don't want to parse it. It's difficult. So this one does all the parsing for you, json.parse. And you immediately get an object. So it's very convenient. You don't want to parse the information anyhow. You get the parsing built into JavaScript. That's the beauty. So
Can you please repeat this Facebook example? what they do in Facebook, for example.
With the Facebook, yeah. For example, you go to Facebook, facebook.com, you enter in your page, for example, you logged in, you click enter, your browser goes to the server, gets the HTML page. The HTML page is it's very empty, so there is no information about your friends or anything, but it has JavaScript scripts there placed. And these JavaScripts, there are many of them, start working in the browser. And they all start doing the same thing. They go back to your server, which you don't see. You don't see how it happens. They just connect to the server and they ask the server, give me what's missing here. Give me the list of friends of this guy. Give me the list of posts. Give me the list of photos. They all go together at the same time to the server. The server prepares this information in JSON and returns back, boom, boom, boom. You can see it if you open the browser, turn on the web developer console, web development tool, or what's the name of this, and it will show you all the connections which your Facebook page is making to the server. And back, you can see what's coming back. In most cases, you will see JSON, 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 JSON. Then it comes to the JavaScript makes this, JSON.parse, it turns this stuff into objects and start working with the objects. That's how it works. That was invented 15 years ago. It was called Ajax. That was the idea at that time. It was possible because in JavaScript standard, this call to the server was invented. The possibility to connect from the JavaScript to the server. It was not possible before with the HTML3 or something. And then they made it possible. And all websites started to use it, unfortunately, because websites start to look ugly. You open the empty page and they start loading. Some of these connections, they break, so the website becomes even slower than it was before. And actually that was a good solution for bad programmers. So they were not able to make the page render immediately. So when you click facebook.com, the request goes to the server, and immediately in half a second, the whole page comes back. It was difficult to do for programmers. It still is. Facebook's still using this Ajax. So Facebook programmers are not really smart enough to make it just like it works on Stack Overflow. Go to Stack Overflow, say Stack Overflow, click enter, and immediately in one page, you will get everything. All the questions, all the answers, all the pieces of information will just in one page with no this Ajax nonsense. How they do it? They make it fast. Facebook doesn't know how to do it. Facebook just shows you the empty page first and then makes many requests to the server to fill up the page. Yeah.
How about, for example, on the Stack Overflow, the water buttons? I think they use Ajax too, but Ajax is not here.
Maybe they use somewhere, yeah. Maybe they use it for promotion, for ads. But the main page, the main content, just pops up immediately, which is...
But I don't think Ajax is a bad idea because the further part of the use be customized a bit based on the previous one. That's my experience with Facebook. For example, on the first part of it, I liked many some type of content, and the next time it goes to the second part of the
Yeah, you mean that's just the endless scrolling. When you scroll down, it loads more and more and more. Yeah, endless scrolling. Yeah, for this, of course, it's good to use Ajax. But this is probably one reason why Ajax is good for this endless scrolling. So you scroll down. It probably maybe even remove what's on top and downloads what's on the bottom. But maybe adapts for something, yeah, gives you different content, yeah. But they download initially everything like this. When you open it up, they put your friends even get in there. Friends, the list of friends on Facebook. Why can't they just fetch it from the database on the first request? Because they don't know how to make it fast, that's all. That's the reason. They just don't know. They're not smart enough. I mean, they have probably performance problems, but whatever. But every time you see Ajax, every time you see that the website is trying to download pieces after the page is demonstrated to you, it's the problem with performance. Programmers just don't know how to fix it. That's it. Because if they make everything visible in one click, then when you go to facebook.com, you will say facebook.com, enter, and boom, you will just stay for 3 seconds. Boom, boom, boom. And then, then you see everything. But they don't want you to stay because you will close the page. So they want to give you an impression that everything is bullet fast, that you click Facebook and it opens immediately. Google even works like this. Go to Google and search. Google immediately check the Google sources. Open the source page of Google. If you click on the google.com, view sources, there will be that size of a page. So there will be just a few lines and then JavaScript. So Google immediately, when you do google.com, it immediately shows you the very small HTML page, which is like really small, but it goes to you very fast. And then this page goes to the server while you already think that Google is right here, but it's not. It goes to the server, it talks to the server and shows you the content while for you, it looks like it's already done, it's already finished. But behind the scene, Google keeps talking to the server, staying on the main page.
So it's more about user experience.
It's about user experience, yeah.
Just want to, by using Ajax, just want to give us the impression that we are.
Yes. Ajax gives you the impression that everything happens immediately, like extremely fast. Yeah, and then the page, you know, goes back to the server and keeps talking, but that can take 3 seconds. But for you, it will be okay because you will feel that everything is right there. Then you click some button like, where are my friends? Ah, the friends are still loading. Okay, the friends are loaded. Okay, cool. That took 2 seconds. But Facebook is super fast. But you know, realize that Facebook is really slow, much slower than Stack Overflow, and much slower than Google, and much slower than Twitter. Twitter also does the same. All large websites, they do this. I mean, I don't know what are the reasons, but it seems that they just don't know how to do it otherwise. So that's JSON. That's what it's for. We have probably a few more minutes. So let me say about 3 more formats. YAML. Do you know YAML? Yet another markup language. Very popular, very simple, does exactly the same, very similar to JSON. Also no schema, no XPath, no XSL transformations, nothing like this. Very primitive, just way to, in a text form, to present the data. Another one is called TOML. Do you know about this one? It's quite useful for, basically for configuration files, not for data, but I still mention it here. So in TOML, I'm not an expert in TOML, that's how I understand the same library should be presented. So we present it this way. Another one is comma-separated values, which is I think, also good stuff, very simple. The first line usually is the titles, ID, author, title. It's like a headline. And then just numbers, comma, numbers, comma, numbers, comma. Sometimes you can use quotes, double quotes to keep things together because maybe you need to have a comma inside. So for this, you need double quotes.
I think it's possible to mention that CSV is the problem of CSV. CSV is just a vague idea of file format. There's no strict grammar for how you should escape, how you separate stuff.
Yeah. So you're saying there are probably no standard which would define strictly how it should be. It's just a concept, yeah, just an idea. Yeah. So you can you can use it differently, and maybe you can write it one way, and then some parser will not even understand what you did. So it's pretty flexible thing. Okay, now some books. So I suggest you what? Okay. Okay, flexibility 0, yeah. So 2 books which I highly recommend. The first one on the left helped me a lot to understand XML. Even though it's quite old already, I would suggest you to read it, at least the first, 50 pages. Definitely need to know this being a programmer. The second one about XSLT. This is what's tricky, again, very interesting. If you're gonna go into XSLT, you need to read this. Some call to action. So in your application, which you develop right now, try to make sure that your data, some pieces of data, represented in XML. And at least in one place, try to make the transformation by XSLT. That will be fun, I can guarantee you. Play with it. You will enjoy it. Why? Try it. It will be fun. If you're interested in functional programming also, you will learn a lot of things from this XSLT transformation.
But it's for fun or for grading?
Fun or?
I mean, will it affect grading?
It will affect grading. If you do this, if I see that in your project, I will definitely increase your grade. In a positive way, not in a negative way. Yeah, and also think about your own data format, which can be based on XML as well. What?
How about inventing a binary format?
Invent a binary format, yeah? Think about inventing some format inside your project. That would be really cool. Okay, what's unresolved? We have like a little bit over time, but still 4 things which I believe is interesting for the future, for you to think about what to work on. First of all, how to map XML JSONs to objects. I think this question has still don't have an explicit answer. Like if you get an object, I mean, in programming language, it's not like JavaScript. So if you get something, if you get a text from the stream and then you want to make an object, or the other way around, from the object to the text. In Java, for example, there are issues with this and could be done better. Second one is how to print object to XML. The opposite operation, how to take the object, the text to the object, and then how to print the object to XML. I'm not sure we have a clear understanding of how it can be done properly in all cases. Number 3 is how to create a common binary format. That's probably maybe for the future, like we have XML for text formats, and maybe something similar will show up for binary. Who ever heard about gRPC?
Yeah, how about protocols?
How about this one? Yeah, protobufs, yeah, and gRPC. That's the movement towards this direction. I'm not sure these are like standards already, which are for everybody. They're used everywhere. Yeah, they're used in many places now. Not everywhere, but in many places. So maybe this question is already answered. Okay, I'm not insisting. And the final question, which is for me very important, how to restore the popularity of XSLT, because it was popular a long time ago, and now it seems that even Chrome browser is thinking about ceasing the support of XSLT. I read it somewhere on some forums that maybe they will stop supporting XSLT. So what do we do with the future? In the future with this format, I don't know, but I love it. Love it very much. I use it everywhere.